Okay, so I want to give you another little session on trig in the real world and making sinusoidals. So if you've got a cosine graph that does this, I hope you've learned now that this is the b term and that you can figure out this thing's period from looking at that b term. So the period for cosine is normally 2 pi over b, and I know b is 3, so I can put a 3 in, and my period must be 2 pi over 3. That means this thing will finish up a complete cycle over this much on the x-axis, between 0 and 2 pi over 3, for example. All right, and then this is a phase shift, and since the 3 is already factored out, the phase shift is just right pi, and that would mean I'd grab my whole cosine graph and drag it to the right pi. All right, but this is more about taking a real world situation and making one of these cosine graphs, which are ironically called sinusoidals. All right, so I'm going to give you another scenario that you haven't seen before that might help you understand this. So imagine for a moment that you are standing outside of a tiger cage. So you're standing here, and if you haven't seen this, sometimes animals will pace inside of a cage. That's one of the sadder things that happens. And let's say that the tiger is pacing back and forth. He gets up close to you, and then he turns around and goes the other way. And then he gets up close to you, and then he goes the other way. And if he's pacing back and forth like this, you can actually make a graph to predict, as long as they're going at the same pace, predict where they will be at any given time. All right. So what do we need for this? We need a low, which is a low distance between you and the tiger, and a high. All right. Just like we would need on a graph, if the graph looked like this, we'd need a low spot and a high spot, right? So same idea on this graph. How far is the tiger from you when he gets really close to you? Let's say that the closest he ever gets is 2 feet away. And then let's say he has a decent sized cage, and so he is 20 feet away from you when he's at his farthest point away from you. Do you get that's kind of like on this graph? The low spot is 2 and the high spot is 20. So I think one of the best things you can do when you have something that isn't making a curve like in the real world, it's just going back and forth, is to make one of these pictures and label it for yourself and say, okay, the closest it ever gets is 2, the furthest it ever gets is 20, and obviously the tiger goes all the things in between, okay? And then what else do we need? Well, we need numbers for this x-axis. Now, there's 2 different ways they can give that to you. They can just say how long it takes the tiger to pace. You know, if the total round trip of him going out and back were to be, let's say, 20 seconds. Okay, if it's 20 seconds for him to go all the way down and back again, then that's a complete cycle, right? And that means his period is 20 seconds. Now, that'd be pretty nice if they gave it to you that way. Let's say it's a little more complicated. Let's say that they say, oh, it takes 5 seconds for him to get from close to you to far away from you. And this is 5 seconds. Okay, then it's a little harder to figure out the period from that, but it's not that much harder. If it takes him 5 seconds to go from close to far, then of course it would take 10 seconds to make a round trip. All right, so if you're trying to figure out an equation for this, let's do one for this tiger situation. Y equals, and I always leave some room in front of my cosine, and then I leave some room there where I can put my b term, and then this could be x or it could be theta. And now I've got room to put in everything I would possibly need. All right, I might need an amplitude here, and I might need a shift here, and then I might need an upshift there. All right, now it's useful to like try to figure out where that you're going to start this problem. If the tiger just kind of starts in the middle of nowhere, it's more difficult to envision it. But let's say that the tiger starts close to you. Okay, let's say that he starts at that 2 feet away from you. All right, well then, if I'm making my graph, he starts really close at 2 feet, and then he ends up at 20 feet away after 5 seconds. See how that made it really easy? It started at 0 seconds at 2 feet away from you, and it ends at 5 seconds. He's 20 feet away from you. All right, and then of course, if I wanted to add in a little bit of curve here to show that, oh, this is going to be a sinusoidal. All right, now I need each of these parts, and I've tried to tell you before that the amplitude is important and that the midline is important, and I think midline is the most important. So the midline runs right down the middle. Now I'm going to ask you to pause the video for a second and try right now by yourself to, now that I get it all set up for you, try to write the equation for this one. Okay, so pause me and try it. Trust me, you'll do a lot better if you try this on your own first. Okay, hopefully you have gone and given this a shot by yourself. Now I'm going to figure out this midline. The midline runs the average of 20 and 22. So I add them together. 2 and 20 is average. That is, add them together makes 22, divided by 2 makes 11. So the midline is 11. And that means that this is a shift up of 11. So the 11 goes here. Next, from 11 to 20 is the amplitude, and therefore that's going to be 9. And the 9 amplitude goes in the front. Next, see how this is where cosine would normally be at its peak? And so we need to account for how far this has been shifted to the right. Cosine normally is at its highest at time 0. So how far did it shift? It's the x value of the first peak goes here. Okay, so 5 goes there, and it's always shifted to the right. At least it can be, and that's what I would always do. Okay, and then last but not least, I got to figure out that b term. The b term, right here, I got to use that formula. The period is 2 pi over b, and yes, of course, you can reverse them. b is 2 pi over the period. All right, so now what is the period? A common mistake answer here would be to say 5 seconds, but the tiger isn't back where he started at 5 seconds. So you have to double that and say the period was 10 seconds. So then if I put a 10 right here, then it's 2 pi over 10. Yes, you should reduce that, pi over 5. And there we go. Now, what is this formula useful for? It's useful for, this equation here is useful for figuring out where the tiger would be at any given time. So if I say at time, 1 second, how far away is he from you? Well, he started 2 feet away from you, but he's moving away. So he's going to be more than 2 feet away from you. And so you could put in whatever number you want for the time right there. And then use your calculator and type it in, and you can find out exactly where the tiger would be at time 1 second. Okay. At time 5 seconds, I already know where he's going to be. At time 5 seconds, think about that, I know he's going to be 20 feet away from me. So if I put in the 5 right here, 5 minus 5 is 0, and then I end up finding cosine of 0. Flashback to circle trig. Where's cosine of 0 degrees? That's 0 degrees was over here. So, and then this spot in the unit circle was at 1, 0, and cosine is the x, so it's 1. And so then this becomes 9 times all of that, 9 times cosine of all that. Cosine of 0 is 1, so 9 times 1 is 9. 9 plus 11 gives you the 20, and that's where we knew he would be at 5 seconds, is 20 feet away from you. All right, So last thing I want to do is talk about circle trig. And circle trig is super important. I mentioned it before, and we're going to have some circle trig that's going to come back on this next test. So if, for example, I said sine of some angle is equal to 1/2. Well, that's not going to be one of these spots, because sine is either 0 or 1 or -1 at those spots. Take a second and try to remember how there's two answers for this, and you're going to draw right triangles somewhere in the quadrant 1, 2, 3, or 4 where sine is positive 1/2. I'm going to give you this reminder too, ASTC. Again, I would pause for a second, try this one yourself, come back in a minute after you've given it a shot. Okay, hopefully you've given it a shot and you're back. So sine is positive, which means it must be either in this quadrant or this quadrant, because of all of them are positive there and sine is positive there. So it must not have been here or here. And if sine is opposite over hypotenuse, here's the central angle, that's the important one. Sine is opposite and hypotenuse. This must be square root of 3. Opposite and hypotenuse, and this must be negative square root of 3. It's not going to really matter in this case, but I need to know what the angle is. All right, well, if sine of the angle is 1/2, sine, what's that triangle that has the 1, 2, and square root of 3? Oh, that's the 30, 60, 90 triangle. So that's a 30-degree angle. 30 degrees, or what you should write, because usually they're going to ask radians, is pi over 6. And the other one was a whole bunch of 30s. Because remember, I know this is 30, but 30 degrees is located over here. So this is a bunch of 30s. How many 30s? 5 30s. Because think of it this way, all the way around to be 180, but we're 30 degrees less than that. So 150 degrees is your other answer. And I like to think of that as 5 pi over 6. So there's an example of some circle trig that you're going to have to know too. All right, that's all I got for you for today.